Hi, and welcome back to Visual 3D Basics, and in this chapter we are opening Visual 3D for the first time. So we just want to give you a brief tour of what you're seeing, what it's for, so that you know what to expect later on when we use various features in the various parts of Visual 3D. The first thing you see when you open Visual 3D is the Workspace. This is where you will view all of the files. Of course, the first time you open Visual 3D, there's nothing there. But once you load files, which will be done simply using a very standard looking button right up here in the top, these files will end up in a list right here under Motion Files. Now, these motion files are simply of a motion that you previously recorded. Whatever data's in there, that's what will be listed in here. But these don't really have any real significance as a standalone, as you need a way for Visual 3D to interpret the data that's in that file to turn it into some kind of human motion. And that is why you will also end up loading models/calibration files. Typically, you'll probably have one of these for a set of motion files, but there might be a number of calibration files, and you can find other tutorials here at Biomechanics.com as to why that might be. But this is the list of where these calibration files will be. And you'll see even in this specific unit of Visual 3D Basics, we are going to use two sets of data with two different calibration files. And since we are talking about calibration files, let's go ahead and go over here and look at the Models tab. Now, of course, since we haven't loaded anything, here in the Models tab, we really have nothing. But this is where we are going to build our biomechanical model, and any landmark or point of interest that we are trying to track, we're going to define it all in here. So that once the biomechanical model has been defined, we can come over here and look at signals and events and see how that model built onto our motion files performs. And we'll be able to graph various types of data and look at it in detail. And we will also, in this area, be able to view the calculations that we perform. Now, there are a number of ways to perform calculations. We will show you a few different ways of doing this, but primarily you will find very quickly using the pipeline is the best way to perform pretty much any calculation. As you can see here, we have a list of commands on the left-hand side, and we can add them to our main pipeline. So you see here, I just select one. If I double click on it, it ends up in the center of this window. You'll also see that there's a right pane, and this is where the details of this command are. We can view these details, but beyond that, we can also edit the text, and some commands even have a graphical interface for you to be able to select a few different options to make it a bit easier. All of this is a way to make processing your data easier. But throughout this course, you will learn how to do that, as the first time you look at it, it might seem intimidating. The purpose of all this is to show you that it is not intimidating, you just have to learn how to do it. And we're going to focus on that. Now, once you have actually performed all the calculations you want and figured out what you want to report, you can create a report in this tab called Reports. In here in the report, you can create whatever page you want, any number of pages, and various graphs on which you can have a number of different graphs added even to the same graph, where maybe you are comparing right and left, and you can show the difference between the two. You can time normalize them as well so that the comparison is done best. We will get into a lot of details on how all of that is done in Visual 3D, but that feature is part of this course as well. Now that you have a bit of an idea of everything that you can do in Visual 3D and what it looks like, let's start actually doing things. So the next chapter of Visual 3D Basics, we are going to show you how to open files for the first time and a calibration file and show you where everything ends up so that you can start building your biomechanical model.